Okay, today we're going to review how we solve inequalities in one variable. So remember that we use an equal sign when we're going to do equations, an inequality symbol when we're showing a relationship between quantities that are not equal, or sometimes it could be equal or greater than. So like here, less than or equal to. Inequalities typically have infinite solutions. It's very rare to have no solutions, but it can happen. Also, it can have all real numbers, which means we would shade the entire number line. So that also can happen, but it doesn't happen very often. Because there are usually infinite solutions, we do like to show them graphically. So when we're doing a single variable inequality, we shade using a number line. If we are doing a two-variable inequality, we shade on a coordinate plane. And when we're doing a system, we're looking for a region that's shaded multiple times, so overlapping regions. Okay, so when we are graphing on an inequality on a number line, such as x is greater than or equal to -1, remember that that symbol right there tells us that this is included. That means we're going to do a filled in or closed circle. So it is part of the solution. So we're going to say that that is part of the solution. And so you can see right there, that is a closed circle. This arrow is pointing to the right. And so we have our solution pointing to the right. In interval notation, if I were to ask you to write this answer in interval notation, we would be starting at -1 and going to infinity. An open circle, remember, tells us that it is not part of the solution. So in this case, our open circle is not part of the solution. Let me go back up here. There. So we have x is less than, that arrow is pointing to the left, and we're going to put an open circle. Now, it's kind of hard for you to see this on your paper, but I just want you to see that is an open circle right there. Okay, that is an open circle. All right. All right, you're going to do this section right here. So you will do these. All right, then down here, how many solutions are there for this? So we just stated that above. There are infinite solutions, okay? And that is why we're shading. So you're going to write that here, that there are infinite solutions. What is the smallest solution? The smallest solution, or sometimes the largest, is the boundary point. So we're looking for that boundary point. We do that actually by solving for an equal sign. So we do this just like as if we were going to solve with an equal sign. So we're going to take this and just solve the equation. I'll do it over here to solve our inequality. Remember, we're solving exactly the way we did an equation. So we get x is greater than or equal to 4. You can see why they're saying it's smallest, because everything has to be bigger or equal to 4. That is our boundary point. So the boundary point in this case is at x equals 4. So what is the significance? It is the solution to this equation when it is equals. It's an equation. And it also tells us where to divide our number line. So in this case, we're going to be dividing it at 4, and it has an or equals to, so that means we're going to put a closed circle or filled in circle. The arrow is pointing to the right, so our solution will go to the right. Okay, so again, I'm just going to put right here, we used a closed circle or a filled in circle. And our solution shows that we want to graph to the right. Okay, you are going to then do these. This one right here, just kind of when you simplify it, kind of think yourself through what your statement means so that you can get your answer. Sorry about that. Also, some reminders about when you are multiplying. The only difference when we're doing inequalities, or one of the big differences, is if you multiply or divide by a negative when you are solving, you must flip the inequality sign. Okay. And we're going to see that happen down here. So now when we have compound inequalities, notice this has 2 parts. You really just do each part on its own. So we're going to just take that first part and we will solve. So I'm going to add 8 and then divide by 9. So b is less than or equal to -2. We're going to use a closed circle at -2, and our arrow is pointing to the left. And then we're going to put that or. We're not going to forget about that word. It's important. So again, we'll subtract 10, and then we'll divide by 2. And we get b is greater than or equal to 0. So again, we'll use a closed circle. Okay, and then we're going to go to the right. Again, we're going to use that word or. This word or is important because it tells us that this is for numbers that are in this area, or they're in this area, or where they overlap. They don't overlap. So we can pick numbers from here or numbers from here, and it will make both of these statements true. Well, this will make this one true. This will make this one true. When we have these kinds of solutions or problems, typically our number line looks like this, where we have arrows going in opposite directions like that. That's what your typical solution looks like. But it is possible where you actually have the entire number line, because it could be all of those numbers. When we do this one, we have the word and. When we're doing and, these are numbers that have to make this and this true. So it has to make both parts true. They're going to be the overlapping regions, but we again still solve this individually. So I'm going to add 4n. At the same time, I'm going to add 5. Just so I can move all my variables to one side and all my constants to the other side. Now, here's what I was talking about. We have a negative right here. I'm going to be multiplying by -1 or dividing by -1. It's the same thing. But when I do that, I'm going to get n, and this is going to flip to the opposite direction, -12. So now n is greater than or equal to -12. Now, I'm going to put a closed circle, and I'm not going to put an arrow. I'm just going to put that this is going in that direction. So it's headed that way. We're going to be looking for the overlap because that says and. Okay, then we're going to do this problem. So same thing. I'm going to subtract my 3n, add 9. Again, I'm moving my variables to the left and my constants to the right. That gives me 3. I'm going to divide by 3. So I get n is less than 1. We have an open circle this time. So at 1, we have an open circle. And this time it's going this direction. So you can see we have an arrow going this way, I have an arrow going this way. They're headed toward each other. We're looking for the overlap. So the overlap will be the part between those two boundary points. Okay, so typically, a typical AND solution would have endpoints of some kind, open, closed, and then it ends like that. But it is possible, if I'm looking for overlap and my arrows were going this way on an AND problem, this would have no overlap, and so then we would get no solution. So it does happen, but not very often. Okay, you are going to answer the summary questions, and you are also going to do the independent practice.